Yes, my name is Mark Fraser, and I'm appearing on behalf of myself and my company, Oilfield Connect.
Thank you very much. Whenever you're ready, Mr. Fraser.
Yeah, I'll just briefly touch on what my company's doing with relation to the oil and gas, supplying equipment related to the downhole with regards to casing the well, completion or the drill string. Myself personally, I've had 35 years experience in the industry in the capacity of manufacturing, repairing, inspection, recertifying equipment associated with downhole for upstream. So just a couple of slides here showing various different tools that my company gets involved in supplying. These are conductors, various equipments for drifts, handling, some inspection capability, and then monitoring. This is an important thing that the panel might consider in some cases where you're talking in complex or high criticality manufacture. We use a quality control plan, having a third party witness that part being manufactured to ensure compliance. So I'll launch into the presentation, and I've picked, I have a submission which I've already put in. I think you've read that before, and put some of that into the interim report.
Yes, thank you very much, Mr. Fraser.
So I've done my best not to repeat that, and try not to give you a couple of subjects that maybe no one's touched on.
Excellent, thank you.
A couple that are probably a little controversial, but we'll see if we can challenge people's ideas.
Thank you.
So the first two is going to be about dealing with the herd effect, the consensus view. And the second, we're looking at climate change. And now I'll just touch on a little bit on well integrity with regards to some misinformation concerns. And last, we'll talk a little bit about jobs locally here in the support side of oil and gas, not the operator side.
Thank you.
So when I read the interim report, something jumped out at me about climate change being mentioned, and I noticed on a quick search, I think there was about 22 occurrences of the term climate change in the report. So I thought I'd just do a little bit of research in that spot and see where it takes me. And what I discovered is that we've got these things going on in the public where we've got 97% and 95%. And there is out in the community a 97% consensus view that the climate change is real and it's warming. So we can see here from the NASA side, they show a trend going up for modelling, and they talk about consensus and they talk about warming. So what are the facts? This is another part underneath on that same website where they actually refer to peer reviews that they come to consensus of the 97%. So I looked around and we find that there is a report that was put out here by Bedford Cook which talks of 97%, and that's what they're quoting from. And I read down a bit further below it, and then I found this paragraph, and there's something that stuck out at me very, very sharply, and just, they got this, I'll put it in red here for you. While 66.4% of the abstracts expressed no position on human-caused global warming, of those that did, 97.1% endorsed. So basically they took a sample of 11,944 abstracts. Because 66.4% were mute, they threw them out and looked at what was left. I thought that was rather bizarre. So I dug a bit further, and there's these three terminologies used in discussing how they come to these views, and one of them is, as I go up here, the unquantified views, where human cause some global warming. In other words, we may be insisting, but it's not measuring how much. It might be a little bit, not much. The quantified view, which is the one that the survey is meant to be looking at, is that we cause most of the current warming. And then, of course, there is the alarmist view, which is that it's dangerous and we should do something straight away. And then looking at this here, there's this report that was done against the Cook report to analyse how they come up with the numbers. And this is how the statistics break down. And sorry, the colour's not very good up there, but the total sample of these reports, makes up the 100%. They've already excluded 66.4. 32.6% of them were actually marked as being causing some, but not explicitly. So we come down to those which are marked as having the consensus view. So the only one that were endorsed was actually the 0.3% that was endorsed by the authors of the reports. So that changes it from a 97.1% to a 0.3%. Then there was the leaking of emails from IPCC, and in the emails there was communication between the scientists, and some of those are coming out and were posted out on the internet, and some analysis were done on them. And by this paragraph here, you can see an email that was being between some of the members there, and it's pointing out that they've got 600 with PhDs versus 2,000 without. They're aware of it, but they're okay to try and fluff the numbers. Some of the scientists then had left the IPCC and they began a project called the Petition Project. And this is available online. So the Petition Project, they come up with 31,487 scientists who have signed a petition, of which 9,000 plus are PhDs. And in the petition part, if you read the beginning of the second paragraph here, I'll leave my eyes for this, there is no convincing scientific evidence that human release of carbon dioxide, methane, or greenhouse gases is causing or will, in the foreseeable future, cause catastrophic heating of the Earth's atmosphere. I thought that was rather strange because it goes quite different to what I was led to believe, and I think most people think is the consensus. So again, then, maybe we should be careful when people are using either push-poll or herd effects with numbers and claims of 95 or 97% and how they're coming to them. I'll leave that there as a point. Maybe people want to look into that a bit further and see whether it's a consensus or not. So the second part, I then thought, well, it's interesting that these findings, so I thought, well, what is climate warming? And what is climate cooling, change? So I look at these four terms here, with climate warming being a continuous trend, and they say it's 15 years or longer is the period that you're measuring climate with. And then cooling obviously is a downward trend, and climate change obviously must mean oscillate. So there's a bit of interchangeability in the public as to how they use the words warming versus change. Change would mean up and down both ways, whereas pause would be no oscillation at all. So we look at the man-caused, or AGW, as being the thought that that's the dominant driver for climate change, and anyone who is not in that consensus as being a sceptic or a denier. And these are used as derogatory terms in the media, social media. So why do so many of these scientists not subscribe to the belief of anthropogenic climate change, or global warming, as being the dominant driver? So I sort of look at this in two ways. There's one is what drives climate change, and is the climate actually changing at all? And what we find is we've got these hockey sticks out there, and I think you may have seen one of those presentations earlier today which shows this hockey stick effect, which says we're going to fall, a catastrophic event's going to happen very soon, and these are coming out of climate models. It tends to also show that the history is rather stable, and it's used for alarmism. But the data is actually showing that we've had a cooling period in the early 19th century. We had a warming period in the 20s and 30s. We've had a cooling throughout the 40s, 50s, 60s, 70s. In fact, they were alarming about it being an ice age and we wouldn't be able to grow crops. We've gone back into a warming cycle, But more recently, it started to taper again. Now, some of the data that's coming out is showing that, and this table here is to 2015, is that we're at 20 years plus of a relatively stable, or what they call a climate pause, which means it's neither warming. If this is true, then it's neither warming nor is it changing, which says a lot about what we should be thinking with regards to alarmism. Now, what does IPC say about this? Well, IPC recognise that the global warming pause, they recognised it in 2012, that the pause is real. So the custodians of the models themselves come out and said that it's real, that the pause is on, and that the climate models are not reflecting what's really happening. And they can't explain why it has been in a pause since 1997, despite carbon or CO2 emissions increasing. And this sort of graph sort of shows the kind of divergence there is between real data versus the models. And this illustration sort of helps explain a little bit of what those people who are not agreeing that CO2 or methane are the big drivers, why they're saying it may assist or contribute but not be the driver. The claim is that water is making up, atmospheric water, whether it's in vapour form or precipitated, is make up 95% of the effect. And we can see there that carbon dioxide is making up 3.62%, but only a small portion of that CO2 is caused by anthropogenic causes or activity. So essentially, if we were to talk about something like changing from coal to natural gas, we would be reducing the amount of CO2. We'd be taking that little red band and reducing it a bit. Probably puts things back in perspective from the point of view of what these scientists are saying. One of the claims is that with CO2 is that its warming effect dissipates very quickly. Most of the carbon's warming effect occurs in the first 20 part per million. I don't know if that's true, but this is what the scientists are saying. They're saying that plants need at least 150 ppm. Below that, they start dying off. And an optimum, and often used in greenhouses, is around about 1,000 to 2,000. The current levels of CO2 have risen from about 280 to about 400 in the industrial era. Taking a longer scale, and these models showing temperature in the blue, where there's 4 ice ages, and from current temperatures, it's showing that we're technically speaking in an ice age on the long terms, over 600 million year. The black line showing the representation of CO2 in the atmosphere is showing that historically it's been much higher than it is today. And it's also showing that there's no really strong links between CO2 rise and fall versus temperature rise and fall, which again is one of the reasons why that they are believing that the models are not so accurate. Okay, finish with that one. I'll just a concern I have with well integrity, misinformation. And this is coming out in information that's being pushed out by, say, Lock the Gate or Don't Frack Northern Territory in pamphlet form to the public as a form of information that they can rely upon. And we have these brochures and they show these images, and of course one of the most concerning things that people have would be this image here, which would show a leakage out of the well directly to the aquifer. And I want to challenge that a little bit. And the reason I would say that I think that'd be highly improbable is to take a look at how a top view down cross-section of the well looks like. You have the outer conductor. You have 3 layers of casing with cement. And you have in the red there, the annulus. And the annulus is an empty void space. So unlike the image, the previous image, I'll just go back to that, which is kind of showing that the fluid is running up the casing all the way up and then just finding a pathway. So you have an annulus, and then inside that annulus there's the tubing, the production tubing, and the gas flows inside the production tubing, not the casing. So if you layer over that the image of what the pamphlets are trying to say, they're saying it looks something like this. There is no tubing, the gas is in there, and there's somehow a leak path through 3 layers of casing. And I think most of us would look at that and say that's sort of absurd. Now, just going back to this image again and looking at the tubing, how the tubing is, when the well is cased and perforated and fracked, and the completion is lowered in with the tubing, and it's all pressure tested and they flow it. That tubing over time, if it has any corrosion or if there's a leak or anything, what will happen, it would make its way to the annulus. And in the annulus you could detect it. It'll be either pressure or you could sense the gas or liquids. And there you would have time to kill the well and take mediation action at that point to replace the tubing. Yeah? And I believe there's periodic points where they can do that. They can run checks on the tubing for the condition of it like you would do anything that wears or that's consumable. So they would then just bring in a truck like this, which is a workover. It's easily mobile, go out and can retrieve, it can kill the well, it can retrieve the use case tubing and replace it with a new production tubing and reflow the well without any concern of it then further going through the casing and out into the aquifer. So I just use this as a bit of an illustration because we hear this saying of 6% of wells or fail, and this word fail. My first example I'm saying to use a brake pad on a car, something everyone would be familiar with as a wearing part. So if you sent your car to a mechanic shop to check the brakes and they measure the thickness of the brake pads against the manufacturer's specifications for acceptable wear, and the brake pads are found to be worn below acceptable measurements, and the mechanic replaces the worn brake pads with new brake pads, would you call this a brake failure? Or would you call this proactive or scheduled maintenance? I think most people would call that maintenance. That's what you do, you maintain your vehicle. You would call a brake failure that your brakes didn't work and you crashed into something. So we take that analogy and put it to the production tubing and how it is separate from the casing and able to be inserted and retrieved separately. So if you perform a periodic inspection on the production tubing condition and it's deemed to be outside the acceptable serviceable specifications, and you replace the tubing with a new production tubing, would you call that a well failure, or would you call that proactive scheduled maintenance? Again, I would say that is maintenance. That's what you should do. This would be, to me, typical, whether it's onshore, offshore, whether it's conventional, unconventional, CCD or shale. Basically, that well configuration is the same. The method of the tubing providing the primary barrier, which is able to be replaced, and the casing, multiple layers, providing the multiple secondary layers. Next one, I just want to touch quickly on jobs. I've seen a few presenters talking about jobs in different ways. About this time last year, I shut down the only oilfield service machine shop in Northern Territory that could machine the threads on the oilfield casing and tubing and drill string, and retrenched all my staff that had worked with me, including guys that I'd trained up over a decade. And we sold off, disposed of all the assets, and the capability is no longer here in Northern Territory. So while people sometimes mention probable, possible, maybe jobs impacted, the moratorium 100% did affect a number of people's careers. A number of those people are still struggling to find full-time work today. If they have got jobs, they're not in a pay of similar or a career of similar level. So this is an article on when we shut this down. So there was a direct impact. This is looking at the facilities. We have a workshop with a lot of infrastructure for handling OCTG, casing tubulars and drill string. You see a lot of pipes stacked in the yard there for servicing and repair. Inside the workshop, we're working with bucking machines to make up completion assemblies, casing shoe track assemblies. Actually, the image to your left in the background is two cylindrical shaped pieces. Those are called spools. They were property of Pangaea. We were servicing those at the time of the moratorium announcement, and shortly after we had an email to say that all that work was off, and we returned all that back to Pangaea. So we were doing work at that time. Here's some more equipment and lathe machines, machining up specialised equipment. These are conductors. These are for offshore particularly because they're larger size, they're 36-inch conductors, but we had welding procedures for welding to API 1104, which is for conductors. Decoded welding. Some other ones showing large machinery that we use. There's a 36-inch PGB retrieval tool and some threads being cut on the far side. Here's some other equipment we're working on. This is maintaining starting from your left, there's some flow, what they call a flow head, had to be stripped down. All the components resurfaced, new seals and things put in, and hydro test, and has a specific procedure for multiple chamber testing. There's some other one in the top centre, which is some risers, which had to be fully stripped down and serviced. We subcontracted a lot of work to local inspectors and welding fabricators to do work that was coded. In the lower centre, there's some perforated tubulars. And on the right, that section there being lifted up is on the Montara after the well was put out and they've cemented inside. This is the cap that was going on top. We made up that cap to go on top. We also made components of the relief well that went in. Comparing our company in Northern Territory to those of our competitors in Australia, and this graph has gone off the edge a little bit, but we're at the top there. We had a total of 52 individual thread qualifications in Northern Territory, and the nearest competitor in Australia had 26. So I used to love hearing people come to the Northern Territory and say, in the territory we need to increase our standards and our capabilities to attract work, when we were doing double the capabilities. And just on the KPIs, while we're on this slide, at the time we shut down the facility, we had over 1,200 working days, no lost time injuries. And the lost time injuries before that were minor in nature. The person was back to work within a day. We had one quality escape in 12 and a half years of my tenure, and it was non-consequential. That was picked up on a rack. And we had no environmental escapes or regulatory escapes. These questions I put up, they're a little bit rhetorical, and they're not aimed at obviously this panel or the operators within the oil and gas industry who were not obviously subscribing to having a moratorium. I'm looking at the impact here that's probably not being thought about. So in a post-moratorium area, let's say that the moratorium has been lifted. Who's going to reinstate the small and medium enterprises that was supporting and servicing the oil and gas industry? How do you bring back the capabilities? I mean, it was easy to turn off the switch and remove the customers and cause those companies to implode. Was anyone thought about how you put them back? Who's responsible for reinstating those capabilities? Who's responsible for upskilling and training people back to the level that they were at? Has anyone thought about the plight of the workers who lost their jobs and their livelihoods were, and are in many cases still ongoing, are being impacted? Just food for thought. I've got a second presentation which I slipped on the back of this because it's a technical, it's an old one, and I haven't looked at it, and it's a bit wordy, so bear with me. I'll try and muscle through very quickly. It may be very important for the panel to see this because it'll do the technical side of casing itself. So the OCTG, I'll just stick with that. The acronym OCTG means All Country Tubular Goods. It's a standard name for all casing and tubing in oil and gas. The first one's on directional drilling, and I just put this image up here and you see the bend sub there which I've circled. I've manufactured those in about 1982 as an apprentice. That's how long bend subs for directional drilling have been around, and they're old drawings then. And that's an old technology which I don't think they're hard to use anymore. The first case of directional drilling that I'm aware of was by Eastman, in which in 1934 he designed the whipstock to kick a string, and they still use whipstocks today. It's not a defunct technology. The problems with using either bend subs or whipstocks to kick in that is that you have to keep pulling the string out to run wire lines to see where you're up to, and then go back and drill a bit, and then go back and see where you're at with logging equipment. So the invention of putting monitor while drilling, MWD, or logging while drilling, LWD, in with the tool assembly, and then having a steerable motor head that you can literally steer it through and get live data, obviously makes great efficiencies with the ability to horizontally drill. So I just put that out there as that horizontal drilling is not this thing that just happened yesterday. It's an evolving technology that's getting better and more efficient all the time. There are other ways of directional steering a well, using jetting and so forth. Now as we go into OCTG, just want to touch on ISO. Everyone knows what ISO is, but they think it's just for managing an office environment. But no, there's many other standards in ISO. And ISO, and there's a lot of homogenising now between oil and gas standards and ISO standards, and this is an ongoing process. But there's literally so many standards, and we should keep standards being separate to the meaning of regulation. So some people mix up the two. Standards are there, they're well developed, and they're on a constant improvement process. When we deal with OCTG, which is all country tubular goods, we're dealing with casing, tubing, particularly, and the accessories that go with them. There are a number of standards and sub-standards with that. So API 5CT is the parent. I'll just put there. But you can see there's a number of others there, like API 5C1, API 5B, and so forth. They do specific other things. There are threads that come with API that are standard within the API standard, API 5CT standard. But these threads are not gas tight. These are okay for liquid, so okay for say oil, water, but not suitable for gas. So you would say these are okay for probably on the outer casing, surface casing example, they'd be fine. But you wouldn't want to have those to be in your inner primary necessarily. I mean, it's still up to well-designed engineers as to how they go about it. Now this is actually a bit confusing because the sign says no gas, actually that has a gas seal. It's actually 2 images and it was timed. So the original image showed the thread without the seal, and the arrow there is actually pointing to where the addition of the mechanical seal is machined onto the end of the threads. The companies which design the threads to go onto the casing go through a rigorous process in which there's FEA done first to do the analysis there, but then they also, you can see up in the upper image, they've got mechanical devices to do tension, compression, bending, burst pressure, collapse pressure onto these to come up with values that show you the capability of the connection so the engineers can rely upon. There's a number of companies that manufacture or are the patent owners of these thread designs. A number of these threads are up there listed. There are websites that the engineers use to get specific information and performance values for the casing and the threads. There's different kinds of threads that are designed for coupled or semi-flush or flush, depending on the applications. I'll skip over this just for time. Going through their specific sizes, basically. I'll just pause on this one for 5 seconds. This is just showing sort of flagging points in time where different material grades arrived. And just to touch on that particular point, a lot of people refer to water bores, or what a farmer would normally relate to as a water bore, which is a different standard. And they typically would use grade 350 as their minimum requirement, which is a mild steel. These materials up here are high alloys, and some of them are nickel alloys, grades which are used for oil and gas. So it's a completely different standard and a different wall thicknesses, and have different properties for instance, for resistance to hydrogen stripping and so forth. So in other words, fit for purpose. It's identification, some colour banding and stuff which you can go into, measuring, equipment to make up. And this is just showing using a bucking machine to input the inputs and make it up. And then there's a graph, like when you're making up a connection, I've got a number of values there which I'm showing. There's a graph that looks good. And the way you read that is, as it's going along in time, you see the lower part, there's no torque. It hasn't lifted, there's no torque. That's just the beginning of the makeup. As it starts to go up, the thread's engaging, and you're getting a little bit of pressure between the box thread starting to expand and the pin end thread starting to compress because it's tapered as they engage, and then it comes up to where it kicks at the shoulder. That's the shoulder of the seal engaging, and it goes up to an optimum band and then it shuts off. If you don't get a gauge like that, if you get something that looks like this, it may be an indication that you have a banding. I think that's about the end of it. Yep, perfect.
Thank you very much, Mr. Fraser. Just before I move to Dr. Jones, I just wanted to get the first part of your talk perfectly clear. So do you accept that climate change is happening?
I'm unsure. I actually started off on that little journey based on the interim report, thinking that climate warming was real and that the consensus was that it was real. And I had no reason to think the other way.
When you say consensus, are you referring to public opinion, or are you talking about
public
scientific
opinion, what's in
literature?
the media. You know, there's that noisy people out there that are saying that the majority of scientists agree that the science is done. Let's not talk about it. You know, anyone else who's against it, then they must be a little bit, you know, in the minority. And I just thought that was about how it was. I had no idea that there was science out there that would refute that. So it was a journey of discovery. But I'm not saying that I have the ability to endorse what they say. I'm just saying there is something that I discovered which is quite compelling. It's compelling because it's not just the detractors or the skeptics or the deniers saying this. IPCC itself has come out and said they accept that their models are wrong.
Have you read the 2016 report?
I have not read that, no.
Right. Well, with great respect, I think you probably should, and I think it's probably fair. Someone will correct me if what I'm about to say is wrong, but I think it's fair to say that absolutely everybody on this panel accepts that climate change is real, climate change is happening, and that's human-caused.
Okay.
So
I
cannot imagine the evidence that we presented at this panel that would cause us to change our views on that. Thank you. Yes, Dr. Jones.
A couple of questions. You showed a very clear diagram of the production tubing, the intraannular space, and the casings. It appears to me that when this term sustained interannular pressure is raised, people think of that as a failure. Whereas what you were telling us is it's essentially a symptom of just the production tubing might be leaking. You go and you replace it. Is that correct?
More or less, yeah.
Okay. And
Because you can imagine if, even if you had a catastrophic failure of, say, the tubing and whatever was inside the production went into the annulars, you then still got to look at the time it's going to take for it to then work its way through the first secondary casing and then the cement and then next casing cement, so on, until you can get to the aquifer. There'll be significant lag time there for them to come and intervene.
I know that the image of Deepwater Horizon is in people's minds, and of course that was sustained interannular pressure that blew the top off the well. But in the case of shale gas, I don't, provided there isn't a failure in the Christmas tree, I don't imagine that would happen.
I've never seen it.
Okay, the second question relates, you're talking about standards and regulation.
Yes.
You're saying the two aren't necessarily related, and I accept that. But on the other hand, we received presentations from, say, the DPIR Petroleum section that says there are N different standards in the world that can be used to do this, and we don't worry which standards the companies use as long as they use a standard. But in my mind, that does put a stress on the regulatory system, because if you've got all these multiple standards that a limited number of people are trying to assess compliance with, and that is an issue. So do you have any comment on how we could perhaps conceptualise this and making our recommendations?
The standards for casing itself and for the drill string are the standards. No, there's no multiples of them. There's just API 5CT for casing and tubing. There's no other. It's not a.
Well, I guess my point was probably a bit broader.
Yes.
For the industry in general,
yes.
there appear to be in terms of well integrity and so on and so forth. There appear to be, and well construction. There appear to be quite a number of different standards. Yes. Which certainly in my mind anyway would be a recipe for regulatory confusion, or at least overload anyway.
Yeah, possibly. Don't know if I've got the fix for you there, but it's sort of like the standards are often related to a specific thing, and it depends on whether you're doing a specific thing as to which standard you're going to apply. So if you know, for instance, the drill pipe's going to be under API 5 DP. The drill collars are going to be under 7-1-2. The wellhead assembly above is API 6A. So there's a standard there covers those things. And they're the key ones, just the ones I just mentioned there. The 5DP, 7-1-2, and the 6A. There's a few of them there that basically cover everything from the casing, tubing, the wellhead, and the drill string that's used during the drilling.
So with these particular construction standards, is it the gas company that makes sure you follow those? And at some point there is the regulator, the government regulator, who comes in and says, how was this thing constructed? Which is another kind of overlay as well. So I guess it depends where you fit in the chain of the system.
From the point of view of a supplier, when you receive an inquiry from an oil company, they're very specific in what they're asking for. So they'll ask for an accessory based on its size, its poundage, its grade, and then other dimensional or features that it requires. Everything that we supply then has to comply to a standard which would be typically API 5 CT for casing, for instance. And everything has to have traceability, and traceability is probably something that's probably not well understood outside of the industry, but very well understood within industry. So essentially when a section of API 5C or OCTG is manufactured at a steel mill, a section is taken off as a coupon, and it's put through a laboratory test to give it chemical and mechanical properties, and that generates a mill cert with those properties written on the cert. Every piece that comes out of that section has a heat number, a batch number with it, and that remains on the product all the way till it goes to the well. If at any time that traceability is lost, it's deemed scrap. It doesn't get used. Anyone who's supplying steel must supply steel from a mill that has been certified by API themselves. And there's actually on API website, they've got ability for you to check the active license of a manufacturer mill to ensure that they are currently licensed to manufacture under API 5CT. So it's a whole process there from beginning to end of maintaining that. So even in a workshop, if you're asked to take, say, a full section from mill and cut it in half and make 2 short pieces out of it, the first thing you have to do is transfer the traceability numbers onto both halves before you cut it in half. Because at any point you lose traceability, it can't be used. And this goes on for also using solid raw bar stock to make other accessories that go into the well. Whenever a connection is made up, the connection make-up with the bucking machine, which I showed before, the equipment that's used to make up has to be calibrated. The staff who are doing the work have to be trained and have to be a training log on them to be properly trained to do that particular task. Every connection that's made gets logged as to the traceability of the material and the piece that it associates with. It has its own unique number. And the graph is kept and maintained as part of the certificate of conformance that goes with the job. And that's for all the mill makeup or the workshop makeups. Separately at the rig, they got the ability to log the makeup of the other side of the connection that they make up on site. So we can keep a full watch on the whole way through from mill through to the well as to what's going in and it's the right material. I think most of the material coming out of European, Japanese and American mills are widely accepted as being okay. Chinese is the thing that people get concerned about. There are some Chinese mills that do produce very good high quality API 5CT in some of the lower grade casings like L80 or P110, but they're still struggling with the high end or the chromium type materials. And there's a few of them that are not quite so good, not so consistent. And I'd say, yeah.
Thank you. Yes, Professor Hart.
You told us about the unfortunate demise of your company and also made us aware of the issues of reinstating, reskilling SMEs, service capability. Could you give us any thoughts, probably from your own experience, of the time that you think it would take to achieve that reskilling, reinstatement of service industries?
The hard thing would be is that to cold start a facility would maybe cost, say, $3 to $5 million. For a small company, that's a lot of outlay, and you'd have to look at a number of factors from the volume of work you're going to get and the likelihood of further interruptions down the track. Whether or not there's somebody down the track, there's another decision to pull the carpet, so to speak.
Yeah.
I'd just like to speak quickly on another area here with regards, I see a lot of people bring up this subject about local content and how that all works. One concern I have, I think is possibly one of the sources of the problem, is the way that procurement logistics is being trained to behave in a fashion that is more like central purchasing. And then what happens is you have purchasing procurement managers, procurement officers based in, say, Perth or Sydney or somewhere afield. They'll tend to use people in their area because that's who's there, that's who knocks on their door, as opposed to having regional procurement people. I think one of the ways to get past that hurdle of getting actual, real, tangible local content is to somehow put into the mix that there needs to be some level of local procurement capability so it's able to be familiar with the local capabilities. The other part of that is also then to homogenise some of the activities of the operators. For instance, if Pangaea, as an example, with Origin and Santos, each require inspection services on an ad hoc basis, and they each have their preferred person who happens to be interstate, we end up with 3 different teams of FIFO. If they combine together and spread the work out sensibly, you could possibly have one local company which had continuous work going from one to the other to the other. I think this is probably the smarter way to move towards generating more local content.
Can I just continue on with that? I think you mentioned how many of your staff you were required to retrench. Was it 17 or something?
No, there wasn't that many, no. We had a bit over 12, but we had 9 at the time we closed, because we'd let some go, we let them.
So 12 had to, you had to
12,
like go 12?
would be the higher end of it, yeah.
Right.
Yeah. I think it's important to understand that sometimes in the language of people's title and who works in the oil and gas industry, I had an electrician, we had about 200 vendors. I'd say 150 of those would be local in Northern Territory here. So we'd be using them for all kinds of things. Some would be only once in a while, some would be every day.
Knock on.
Yeah, all the time. And we had truck drivers who were coming in our yard all over and over again. Some of those truck drivers were owner-operators, and when all the work dried up, I believe they had to sell off their trucks, and there was impacts with mortgage, leave it against their house and so forth. We had an owner-operator fitter that serviced our equipment, and I had to sit down and tell him, we've got no more work for him, and we were 1/3 of his income. So there's all these people that sort of they don't get seen, they're invisible. Some people call it a trickle-down effect, but yeah, it's real to me because I see that.
So give me a feel for the size of the loss of turnover that you suffered.
It's hard to quantify because the difficulty with the kind of work we're doing is that we're fixing things that, or modifying things as they require. We're not the front end where you're buying the new raw manufacture, we're fixing things or modifying things afterwards. So it's a bit like a mechanic trying to predict how many cars are going to break down, or a panel beater trying to work out how many panels need to be fixed. So,
Was it 2 million, 5 million, 10 million?
What's your best estimate?
I'd say just under $1 million.
That's pretty significant. The other point I wanted to get your view on is I could mount an argument that this sort of situation, terrible as it was, is a consequence of our capitalist society and changes in technology, things like that happens all the time. What's your response to that?
Good question. That is true. I think the argument then would be between, we're talking about whether we've got coal, we've got gas, and then we've got renewables. And it's about, what stage are we with technologies and at what pace we need to move and how involved we are with what. I'd certainly agree that we need to start to move away from to coal towards gas. Because there's more things coming up with coal with regards to other things, mercury and sulfur and other things that come into the atmosphere beyond the CO2. Natural gas obviously is a very good fit to come in that space and lowers our CO2 at the same time. We see in America that they're documenting how their transition from coal to natural gas has had a great benefit on their environment. The next thing is, obviously, as you pointed out earlier, is that natural gas is not, unlike coal, unlike renewables, it's also used in manufacturing. Whether it's used as an energy source, whether it's used as a raw feed ingredient into things that are chemical in nature. So we've still got that's going to have to be ongoing with natural gas. Renewables are coming, but at the moment they can't come without a fair bit of grants and subsidies. As much as the label of greed has been laid at the feet of the resource companies, we should also be extremely wary of some of the individuals involved in renewables, that they aren't equally as ferocious at being a bit greedy with how much money they want to make out of renewables and push along a sense of urgency in that sense and go early. There's things like, we look at the lithium battery for South Australia, but when we go back and look at some of the technology used in lithium mining, it's not always environmentally that friendly. They are dewatering from brackish aquifers. They're putting out huge ponds. There is a huge amount of salt drawn up. There's lots of things I see in the processes that have been used in lithium making. And if we look at that on a long time scale of, how many lithium batteries we're going to build around the world, and how much lithium mining we're going to do, and what are the impacts of that. So I think we need to sort of take a step back sometimes and have a quick look at where we are on that process.
Thanks.
Thank you, Mr. Fraser. We've run over time. Thank you very much for your presentation today. Thank you.